Yeah, good morning, ladies and gentlemen. My name is Uwe Wagner. I'm working from the company Sign Incorporated. And today I want to speak briefly about some new idea about the question if traditional L3 VPN are really still required, or is there a shift in the industry that becomes visible, and that's a new path to follow. I will give you just a brief overview of this. We won't go into the deep technical details, but I hope in the end you may get the idea what is changing here, especially from the perspective of the service providers and operators, to really stay alive in business and not get bankrupt due to massive hardware investments they need to do for their router platforms, due to 100 gig deployments and so on. Yeah, so that's the question. Are traditional L3 VPN solutions are still required? The reason why I ask is just the classical approach today. That's what you know, I think, from daily life, business life. You have your MPLS core and edge infrastructure. Oh, this microphone is a little bit flaky. So you have the CP customer equipment as layer 2 or layer 3 devices. You have the connecting PE router, the aggregation routers that just connect the customer traffic into the transport infrastructure. The problem here is just the complexity, but it's not about blaming how it is, because that's just the history, how it grew up. And MPLS was at that time, when it was developed, just the only method to get some predictability into the IP, the nature of wild IP, I would call it, or wild internet. That's what we had at that time. At that time when this came up, I started to work for Juniper Networks, so I come with a quite good background from Cisco and Juniper here. I remember text switching and all that stuff, and the discrepancies between Cisco and Juniper here before they came together really, and also had some quite interesting talks with Caridi Compella at that time. So the point is simply, what we did at that days, we just used BGP, and BGP is not really built for that purpose, but it was the only transport vehicle to transport the information that was able to deliver information crossing AS boundaries between providers. So multi-protocol BGP was built. We got a new address group for the layer 3 VPNs, VRF instances, route targets, VPN IPv4 addresses, and so on. Not talking about OSPF sham links and all the things with imports and exports. That's a nice industry, absolutely true, for all the CCIEs and JNCIEs, yes. People got trained on this, but the problem is, if you want to provision a service from A to Z or A to B, you need specialists. A lot of specialists that touch the equipment, that configure the equipment, and that's just a problem here where providers today need really up to 45 to 60 days to provision a service, to get it up and running for a customer. And one thing should be very clear for everybody in the room and also outside. Running a network is not just for fun. It's not just we run a network because we like to configure and do and make some special routing fancy stuff. No. There's always a business purpose behind. A provider wants to make money with this infrastructure. And I had that interesting talk in 97 when I worked for Cisco with one of our big customers. I was responsible for Volkswagen. And they have a very large network, and they said, it's all nice what you tell us with Cisco here, but in the end we produce cars. We are not here to run a network. The network has to work, yeah. but we are producing cars. That's the key purpose of our business. And that's the same for the service providers. The service providers want to make money on services they can offer to their customers. They don't want to have a fancy network running thousands of protocols and being happy configuring, troubleshooting the whole day. So that's just the key point. That's what we have today. And that's why this little man in the middle sometimes just scratches his head and thinks, is there maybe a different way to do this? And that is what I already mentioned. We come to the point that we have to manage, if we provide services, we have to manage SLAs. So how to manage SLAs? There are quite complex infrastructures there. I even have city carriers in Germany who insist that it is for them. It is like this, that they say MPLS-based layer 2 VPNs are not reliable or trustful at all. We don't provide services and SLAs based on this infrastructure. I don't know, but that's their opinion. They say it's too flaky and too complicated. So the management tools are quite expensive. Troubleshooting is really a complex task, crossing different boundaries of equipment, of responsibilities in the company. The network behavior in general, although you use MPLS, is not deterministic. You know this when you start to implement voice services. You need to tune and trim a lot of things and features and parameters to get really a stable, quasi-deterministic behavior. But that's because of IP. IP is not a deterministic transport mechanism at all. Yeah, it's just a statistical behavior here. And last but not least, if you have a running solution, you get it. The problem is often you need a proprietary solution from one vendor. Then it works. So you live with your Cisco solution, with your Juniper solution, or whatever you use, or Huawei. As soon as you start to use multi-vendor equipment, you have always some drawbacks, some things you cannot do really the way you would like to do them. That's normal, just well known. And I got a quite nice quote from a customer. We talked with the second largest fiber optics carrier in Germany, who told us this. He said, we have 20 large monitors in the NOC to manage and troubleshoot our network infrastructure. But we still don't know what's going on. We see everything, but we have no understanding. We don't know where to touch what and attract what if something is going wrong. That's the key issue they have, because, and that's what many big operators have, because the infrastructure is always a crone infrastructure with different vendors, and there are not really the tools there to manage the SLAs consistently. So the thing that's left to you in the end is what Dilbert says here. No budget for network monitoring software, write it yourself. And he will do this, what about 2040? To be ready with this. And that's just the problem here. So there is not really the fancy nice solution available for managing SLAs, for getting customer services in a nice way up and running in a non-complicated way. Besides that, you always have to calculate the hardware cost of routed interfaces if you have an MPLS-based layer 3 VPN environment. So you know this maybe for sure, or you know it for sure, the price difference between a plain routed interface and a service-capable interface that provides 8 or whatever queues to get some high priority or strict priority queuing running. You pay a lot of money for this. Besides this, with the classical MPLS-based approach, the link bandwidth usage is in the range of around about 50%, sometimes a bit more. The rest of the link you need just for the case of routing failovers. You need to have some spare capacity available here. And if you want to migrate to a 100 gig core, that costs a little fortune because you need routed interfaces, and they are quite expensive, really. That's a key problem. Not only in the access is not the big thing, but in the transit and core infrastructure, it's a lot of money that has to be paid here. And I remember one of my customers from Kazakhstan, it was Kazakh Telecom. They built a Cisco inner core with 100 gig and proudly installed T640s from Juniper on the outside with 100 gig. And they couldn't connect them to each other because it was not really standardized. So they had to live for a longer time with an incompatible solution between the vendors. And it was, as I said, quite expensive. And not to talk about the OPEX for the management of the network and air conditioning, power, heat dissipation and all that stuff, because router hardware just, or this kind of hardware, classical hardware, produces a lot of heat and consumes a lot of energy. So the question is how to get slowly away from this routed infrastructure approach. It's not that routing is bad or is not usable. You need routing infrastructure. You need routing functionality to manage broadcast domains and everything. It's nothing I want to discuss here. It's absolutely clear. But the point is, use it wisely. And is it really does it make sense to build more and more routed complex networks based on MPLS? Yeah, that's the key question, because as I said, MPLS had its time, was nice, was a nice tool, but times are changing. New things are coming up. So what I would propose as an idea, and that's something we do already, is to replace LSP, for example, LSPs with packet optical transport network connections in the core. So even just set up, switch them on lambdas directly. That's like POTN. I don't know who is familiar with this. It's just like SDH follow up, but not with a fixed container and that stuff. It's a different story here, but it's not SDH. But has the reliability and the mechanisms of an SDH that you need for a transport network. It works directly together with the lambda space. So what you can do here, you have a very simple tool if you replace the LSP or transport them over packet optical transport, that you can very simply increase the bandwidth that you require. So it's not a big story to go from 10 gig to 40 gig to 100 gig or whatever you need by adding lambdas, by doing link aggregations and whatever. So that's the first thing in the core. The second thing, the second idea is to replace LSPs in the axis just with E-line services. We will see on the next slide what is meant with this, where feasible, because the whole IPv4 VPN address model is only required to separate the duplicate IP addresses that may come from customers. If you just connect customer routers directly with E-lines, simply provisioned with simple tools and high performance tools, then you don't need the whole VRF stuff and everything. It can be done quite easier, and for the customer device, it looks like that the routers are simply connected to each other, like a link extension, nothing more. So you gain flexible and guaranteed bandwidth with this technology, and you build the base for an easy implementation of 100 gig in the core or in the access as well, where required, and get rid of the complex topology protocols and configurations. That's the key thing. And you can use BGP and ISIS in a just simple normal way as IGP or EGP, and that's it for most of the things. But as I said, that's stepwise. It's not just throwing it all away at once. There is already today the interworking between MPLS-TP and the POTN technology, so that just LSPs are stitched together automatically. These packet OTN devices, they work like P router or PE routers. So you can interconnect via the packet optical transport, the LSPs, and can slowly move your MPLS infrastructure or mix and match it. And the key thing is really, based on this technology, that you get reliable end-to-end SLAs crossing your whole network. So how does it look like if you replace LSPs with stitching? Just if you look at the upper picture, there's an LSP I just made it quite simple, from the PE to PE, crossing the core. What you would do with the packet optical transport devices, you would start to create E-line services on the PE side. And this logo, it's hard to see here. It's just a kind of eroding router. This means the router functionality is offloaded. It's not replacing, throwing away the router. It's just offloading the router with the functionality. So for sure there are services that for customers who want MPLS services, they get it. Other customers who need just connectivity between locations, they can use E-line or E-LAN services over the packet optical transport. And you can hand over it on this side here in such locations that you bring the E-line over the LSP to the other side, or you can do it the other way around. This would mean you would just, instead of using a central LSP in the core, transport an E-line or whatever, or an E-LAN service, and connect the MPLS transport over the core the other way around. So the question is here really to choose the right layer for transporting your traffic. That's the key thing. And if we look at the classical or traditional service delivery, that's what we have today in most of the cases. So we deliver layer 3 services, IPVPN services, based on MPLS layer 3 VPNs. But there's another choice to say, okay, I deliver the IPVPN services directly over Ethernet OTN services, end-to-end between the CPEs or between the PEs, wherever you choose to locate it. Or if you want, with the equipment, you can even go down further and deliver IPVPN services directly over lambdas. This means you have no interaction in the middle. You don't have to touch the P routers, nothing like this. You just bypass them for transit traffic or interconnect traffic. Or just create a hybrid delivery, so you just use the lambda-based switching in the core and use layer 2 Ethernet services in the access and aggregation area. This flexibility is what you get with the packet OTN transport infrastructures. So you choose the right layer, considering what you want to do, which latency you want to have, which reliability, which policies, and so on. This is just what this technology already delivers, what customers are using. And maybe just a side note here, there's a quite large pan-European operator who runs this model. And one of his key reasons, he said, the key benefit he gained from choosing this different technology is that his service provisioning just shrunk from 60 days to 3 to 4 days before a service is up and running. And he says 3 to 4 days is only if we have to patch some cables maybe that are missing, and maybe some paperwork. If cables are patched and everything, we talk about a day or some hours. And the customer has a service, and he said the key feature for us is here, I earn money earlier. Very simple. I don't have to wait 60 days to get the service up and running. No, customer gets it, let's say, in 7 days or 5 days, and then I earn money and can charge him. And that's already for him the return of investment, where he says all the investment we had to do in the infrastructure just pay off very easily. So there are different solution approaches. I'm not really the PowerPoint geek here, so You will see how the picture develops and you understand it. We have really two different possibilities in general. That was the old method on the top left side, based on MPLS layer 3 VPNs. Now with the new packet optical transport infrastructure, you can follow two different models, and that depends on the network you run. There's the topic router offload that I already mentioned. There's also the topic hollow core. What does this mean? Let's start first with the hollow core. The hollow core would mean in the edge area you place the packet optical transport equipment, and these devices, they connect to each other for the transit traffic of your network. Because there are different numbers. Some people say for transit providers or carriers, some say we have 30%, some say we have even 60%. It really differs from the provider. But there's a lot of traffic in the core network that doesn't have to touch the routers at all. It's just pure transit. It just crosses the network. It doesn't have to be processed by a router, not even with label switching. And that's what we offer here. So we would really get connections from A to B across the network, from peering point to peering point. The transit traffic is selected by a router. Yes, there are routers in the network for sure, but they really send, based on the BGP information and the AS path information, just the transit traffic to a dedicated interface or to an LSP or an E-line, a VLAN, whatever you need here, to cross the network completely and doesn't touch the router. And the benefit is the amount or the hop count is just going down massively. Yeah? Crossing your network, the hop count is just 1 hop or 2 hops and that's it, instead of 5 or 10 or whatever. It makes life much more easier. And this just means that the router platforms you have in your network, they are used, they are required, they're not thrown away, but they are just offloaded massively. And that's what we understand with the words hollow core. So the core is hollowing up. It's not always required to use the routed interfaces. And the key thing is here, and that's where your purchasing department is looking at. They say, oh, it's interesting. There's not this $300,000 100 gig router interface anymore. There is just an $80,000, $90,000 switched interface that we need for 100 gig. That's a massive investment that I don't have to do in this case. So you really save massive money by not stressing the routers and the router infrastructures in your network, not talking about the operation cost. Because these big machines, the CRS, the T-Series, whatever, they just consume a large amount of energy, create a lot of heat and whatever, and require a lot of rack space. And that's just, you get rid of this. That's the problem. Or that's a good point. It's not a problem, it's a good point, yeah. With a router offload, this is just where you leave your core nearly untouched and just, as mentioned before, start to offload the routers, the PE routers, by providing VPN services, layer 2 or layer 3, based on Metro Ethernet certified, Metro Ethernet 2.0, E-line or E-LAN services. You get the same functionality. The key difference is you just have service endpoints direct in the devices. You have SLAs between them and reliable SLAs and a reliable transport. So router offload or hollow core, these are the structures, or there's even a mix and match where customers start with the router offloading on the one hand and then start to push transit traffic just out of the core directly on lambdas. And that offloads the routers in the core as well. But as I mentioned already, it's not that we want to kill routers or say it's nonsense. It's not the case. A router has its sense. Routers are used for sure for broadcast management in the access. Absolutely, you cannot get rid of them. You need some access broadcast management here if you have a CMTS or a BRAS or whatever to manage this. And besides this, you also need this for peering setups, for exchanging topology information and so on. So that's for still routers are required, but not in this massive extent as some vendors would like to see it. So the benefits would be BGP left untouched, though there are no new requirements to BGP. Instead, it goes the other way around. You start to offload BGP functionality maybe as well by getting rid step by step of the MPLS in the larger sense. You have far less protocols to manage and to configure, far less protocols in your network. If there's a failure, you don't have to check which protocol you have to look at and then to find the information. You offload the provider edges or the P routers. Easy bandwidth upgrades just by adding ODUs or OTUs or lambdas even, yeah, if required, which is quite simple. Far less capital expenditure investment, that's what I said, compared just a routed 100 gig to a switched 100 gig interface. And the operation expenses, because it becomes far more easier to manage the network. And how, you will see in one of the next slides. SLAs can be guaranteed and are easier to manage. And last but not least, as mentioned, there's an interworking with the existing MPLS-TP infrastructure. So what does SIGN make different in this way? The difference is really, this is what you have in the classic approach. You have your DWDM, your multi-service platform, Ethernet and router. Every vendor has its own element management system. That's why everybody was looking for always umbrella management to manage all this big zoo together. And what SIGN does in a different way here, it's that we used from day one, that started in 2007, really with the development in SDN architecture. It's not the Cisco bandwagon. You know, today everybody is SDN. Suddenly everybody is SDN. We do it from as one of the first guys here, and we deliver a production-ready SDN solution. Ask Cisco if it is production-ready. Then they will tell you, you have to use our other IP or whatever it's called, or Cisco one something. It has to be used, or the same with Juniper. Yeah, they have some SDN functionality, but ask them, is it production ready? Does it run in productive networks? No, it doesn't. And don't believe any vendor unless he shows you the use cases. And that's what we do. We run in over 150 networks of the world, this equipment and this SDN-based solution. And SDN means really it's open. It says APIs. Thank you. Customers develop their own applications, use them in the infrastructure to manage their networks, and so on. So that's really the difference here. So instead of having a distributed operating system platform, we have a centralized SDN controller platform. We have a northbound and southbound API, open APIs, and we have a packet optical transport infrastructure under it, where you provision layer 2 services, where you provision ODN services, where you provision Lambda services. And as soon as there is a standard that is really supported by all vendors, for sure, there will be also other standard protocols being supported here. But what we do today, we support today a quite large group of third-party vendors already. So our customers have Cisco, Exedian, Overture, Extreme, Sienna, whatever equipment, Huawei equipment in their network that's managed in the complete platform, together with the optical transport. And the key message here is what we got from a guy from TDS, the VP of engineering. He said, people talk about replacing routers. We talk about avoiding putting more in. It's not replacing, it's just avoid to put more in. And AT&T gave us a statement. They said, if we have to invest in hardware like we did the last years to keep the pace with the growth of traffic, we will be out of service and business in 2 years because we cannot pay it anymore. It's too expensive. We need a different approach. And that is what you get already today. If you look at managing these networks, it's just an absolute different way of managing. It's the visualization, the control of the complete path through the networks over all the layers, chassis management, whatever, looking down in the cable, see the containers, see where the problems lie, have SLA management integrated, have testing functionalities, inventory management, and so on. And that's all fits very nice to the Star Wars story here. It's three-dimensional. This whole stuff is really in 3D for some real good reason why we do it like this. The proof is something we got last year from ACG Research. They were looking for the business case really. Does it really pay off to do the packet optical hollow core approach? Yes or no? And they just compared a classical OTN solution with the science solution and with a classic LSR, means MPLS-based routed solution. And they clearly said here 71% and over 48% lower TCO than a classical router switched approach. 67% and 34% lower CapEx than the classical router IP over OTN solution that is normally sold and purchased. And they say much faster process cycle times and TCO reductions because of the virtualization, because of the easy setup of SLAs, of connections from A to Z, of SLAs. It becomes very easy to manage such networks today. And that's where I come to the conclusion, to the last slide. So, as I said, MPLS-based layer 3 VPNs, they had their time, yes. They were reasoned by the available technology at that time. Same for layer 2 VPNs. But, and that's the key thing here, the technology shift is here to use a different approach with less CapEx, less OpEx, and a quicker return of investment. And the key topics are already, and they will be everywhere, router, offload, and hollow core. And I want to finish my presentation just with one sentence I heard from John Chambers when I worked for Cisco in 1997. When John Chambers stated, voice will be free because it's data. And the guys from Siemens, from Alcatel, all they looked and said, what did he smoke this morning? Yeah, this was on a CeBIT event. And they laughed about us. Yeah, and we were standing at the CeBIT booth, and they were coming the whole day, the guys from Siemens and so on, and just, you're stupid guys, you have no idea what it is and so on. And you have no idea about signaling, and what do you want to do here? It's all nonsense what you are telling. And now look what we have today. Voice is for free. That's what the history shows. There's always a resistance again, something new. But that's what you will see with the routed infrastructure as well. MPLS layer 3 VPNs, layer 2 VPNs, they had their time. It's not shut off directly by 1 day or so. But you will see over the next years that this will disappear. And networks become far more easier to manage. And with this also more profitable. Yeah, that's what I had to tell you. So I just used that from the web page. And the key thing here with Sign is that software makes a difference. It's about automation. It's about making the network flexible. And yeah, if you have questions, just ask.
You mentioned your software is able to manage other vendors' equipment. So you are really the software vendor or the equipment vendor?
The equipment vendor.
Because if this states the opposite.
Just a second. So, yeah, again.
If you are able to manage other equipment, other packet optical transport devices, you are providing the best software to manage this or the best hardware to...
Okay, now I got your questions. We have two pieces. The company started in 2005 with the idea of creating a packet optical hardware platform. But very quickly they found out that it's not the right approach because the complexity to manage, set up services and so on, that was a key challenge for the operators. And that's what operators told us. So they came to us and said, it's nice that you have a box, but what we need is really the provisioning. That has to be easy for us. And so the company started to turn around a bit, creating a hardware piece. So our customers, some customers, they buy the hardware only and the management. Some customers just buy the management software and use it for their own equipment, where it's possible for SLA management. So we have both parts. We developed the software around this whole project, around this whole infrastructure project, and provided an element management system, and that's what you see. It would be different slides. The whole SDN controller platform that we created is just like an iOS or Android system. So you have the base operating system, that's the SDN controller, and on top of this, northbound, you have apps. And one app is for SLA management, one app is element management, one app is inventory management, and so on. And that is open. So customers also create their own apps for this.
I'm not talking about apps. So today you are perfectly happy with selling only the software and customer buying equipment for other vendors.
That's exactly what can happen.
But you have the agreement with this other vendor?
Yes, there is exactly. There is what we call Planet. Oh, how it's called? It's Blue Orbit, the Blue Orbit system. And the Blue Orbit system is just a joint group of different vendors that bring or that open the interfaces or allow that we can integrate the interfaces into our solutions southbound. So we do this here with element adapters at the moment. And this way, we communicate from the controller platform to this element adapter, and this element adapter uses then, for example, SNMP or XML or TL1 or SOAP or whatever is supported from the third-party vendor to manage it. So that's the way we do it. We do it for Ethernet NITs or NTEs, for RAD, for Exedient, for Overture, down to the provisioning level, and this is getting more. So, but these are the three key vendors at the moment being fully supported. And we have over 52 other vendors where we just get the information for SLA management from. We just poll the devices, we get the history, functionality, and everything you need. And the ring insert, drop add insert, and all these functionality. And this is growing. So that's the open approach here. And that's where we think it's the only way to help the customer really to build a flexible infrastructure.
Okay.
More questions?
Could you please tell us about a bit maybe about debugging such a solution, because the multi-vendor environment and the different attitude to the variety of traffic, in my opinion, can cause some issues which would be possibly hard to debug. How did you solve this issue, this problem?
So the key question is regarding debugging.
Yes, debugging such a structure, debugging malfunctioning in such systems.
And this is where we look, where we derive the information. That's where you have to see a live demo of this. I mean, we can do it outside later on if you're interested in to see this, where we just have the network. We have what we call, for example, the path trace here, the trail analyzer, where you go through all the layers through the network of the components, and every dot you see here, you can click on, you get live information from the network. If there's the receiver level too low, the receiving power level too low, if there is not really the traffic load that should be there, and so on. For example, with this trail analyzer, so there's a massive element management component behind, or SLA management component, that allows you to look into the details. What you would do then maybe as well, also look into the cable or the services. So if a service goes down, or if you want to pull a cable, everything that looks fancy here in graphics, if you click on it, you get all customers and services on this cable, always. So if somebody is on site from operations, says, can I pull this cable? You said, stop, let me check. You click on it, you know, no, don't touch this, because we have to inform these and these and these customers before we do something. All this information is flowing together, and we get it live from the network. What is not included is something like an Etherreel or Wireshark. That would be the next step, just to connect it. This would be then the final thing for sure, yeah, to get just the packet debug and packet dump from this. But besides that, all possible causes of errors are derived from the live network. There are no databases that can be inconsistent between different status. It's really fetched live from the network. And that's how it works. So we have also quite excessive experience here with our service we call PLNOG. That's a team that really supports customers in the NOC directly. They even run the NOC for them if they start with our solutions for some days to do a slow handover and train them. And a good example is here, for example, Verizon Wireless is one customer, or Windstream, they are the operator for the backhaul. They just started with our equipment 3 years ago, purchasing, I think, about 30 nodes, and after some weeks there was a lot of trouble because nothing was really working. And they were complaining. And then our customers guys went on, they said, what's the problem? We said, the way we provision services doesn't work this way. And they said, okay, then explain us how to do it. And then we implemented the workflow, how they provision services, just in the management software for them. And they were happy. And after 3 years, we talk about 3,700 nodes in the network. They're just provisioning like hell. It's unbelievable. Because it's easy. Point, click, point, click, point, click, and that's it. You really just go in the network structure from A to Z, like a rubber band, connect them, and set up the services without knowing which IP, VRF instance do I have to use, which LSP, whatever. No, it's a different way. Yeah, it's just easy. And that saves a lot of time for the customer. But I'm already over time a bit, so more questions.
Any questions? So thank you very much for your speech.
Thank you for your time.